The future of transportation is already here. The rise of self-driving cars promises to revolutionize how we travel. But how do they work? What makes a car drive itself without human input? In this video, we'll break down the technology behind autonomous vehicles, unveiling the complex systems that allow them to navigate roads, avoid obstacles, and make decisions. From sensors to artificial intelligence, get ready to explore the cutting-edge innovations that make self-driving cars possible. The evolution of self-driving cars. Self-driving cars have been a dream for many years, but recent advances in technology have brought them closer to reality. The journey began in the 1980s, with experiments by engineers and researchers like Carnegie Mellon University's NavLab project. These early prototypes were limited by the technology of the time, but they set the stage for future breakthroughs. The 1990s saw improvements in sensors and computing power, but it wasn't until the 2000s that things started to accelerate. In 2004, the DARPA Grand Challenge was held, challenging engineers to design autonomous vehicles that could navigate a 142-mile desert course. This event marked a turning point, as it showcased the potential of autonomous technology, with teams like Stanford Stanley taking the lead. The race spurred investments from major tech companies, automotive manufacturers, and startups, all eager to develop self-driving car systems. By the 2010s, companies like Google, Tesla, and Uber were at the forefront of self-driving car technology. Google's self-driving car, now known as Waymo, became one of the most famous examples, logging millions of miles on the road and pushing the boundaries of what autonomous vehicles could do. The core technology: sensors and cameras. At the heart of every self-driving car are a combination of sensors, cameras, and radar. These technologies enable the car to perceive its surroundings, understand the road, and make decisions in real time. LiDAR, light detection and ranging. LiDAR is one of the most critical sensors for autonomous vehicles. It uses lasers to create detailed three-dimensional maps of the car's surroundings. This allows the vehicle to detect obstacles like pedestrians, vehicles, and road signs, even in low-light conditions. LiDAR provides precise depth perception, helping cars navigate complex environments, such as urban streets or busy intersections. Cameras. Cameras play a vital role in understanding the world around the car. They provide high-resolution images that help the vehicle identify road signs, lane markings, traffic lights, pedestrians, and other important visual cues. Many autonomous vehicles use multiple cameras positioned around the car to provide a 360-degree view of the environment. Radar. Radar sensors use radio waves to detect objects and measure their speed. Unlike LiDAR, radar can work well in poor weather conditions, such as rain or fog. It helps the vehicle identify the distance and velocity of objects ahead, crucial for safe driving, especially in fast-moving traffic. Ultrasonic sensors. These sensors are used for close-range detection, particularly for parking and low-speed maneuvering. They help the car identify objects in its immediate environment, such as curbs or other vehicles, ensuring the vehicle can navigate tight spaces safely. The role of artificial intelligence. Self-driving cars rely heavily on artificial intelligence, AI, to make decisions. AI helps the vehicle process the data from its sensors and cameras and turn it into actionable information. This is where the car's brain comes into play. AI-powered systems use machine learning, neural networks, and deep learning to understand the vast amount of data they receive. These algorithms allow the vehicle to learn from its experiences. For example, a car might analyze millions of scenarios and figure out the best way to handle a sudden obstacle, traffic jam, or complex intersection. As AI systems continue to improve, self-driving cars are becoming more capable of adapting to different driving conditions, such as new cities or weather challenges. One of the key areas where AI is used is in decision-making. Self-driving cars need to decide when to stop, go, speed up, or slow down. They also need to determine the safest path forward. AI systems process this data and make split-second decisions to keep the car on track. Mapping and localization. In addition to sensors and AI, self-driving cars use highly detailed maps to understand where they are and how to navigate. These maps are often more precise than traditional GPS maps, allowing the car to pinpoint its exact location within inches. Self-driving cars constantly compare their sensor data with the high-definition maps stored in their systems. This helps the car stay on course, even in complex environments, like cities with multiple lanes, traffic signals, and construction zones. The car also updates its map in real time, continuously adjusting to new roads, detours, and changes in the environment. Vehicle to everything, V2X. Communication. One exciting development in self-driving technology is the concept of vehicle to everything, V2X communication. This allows self-driving cars to communicate with each other and with infrastructure like traffic lights, road signs, and even pedestrians. V2X systems help vehicles talk to one another, sharing information about traffic conditions, accidents, and hazards. This communication helps self-driving cars make even more informed decisions, improving safety and reducing the likelihood of accidents. For example, if a self-driving car receives a signal that a red light is about to turn green, it can prepare to accelerate. If a vehicle detects an accident up ahead, it can alert other cars in the area, giving them time to slow down or take alternative routes. The challenges of autonomous driving. While self-driving cars hold great promise, there are still significant challenges to overcome. The technology is advancing rapidly, but it's not without its limitations. Weather conditions. Bad weather, such as heavy rain, snow, or fog, can make it difficult for the sensors to accurately detect objects. While radar and ultrasonic sensors are more reliable in these conditions, LiDAR and cameras can struggle, making the car less reliable in poor visibility situations. Ethical dilemmas. Autonomous cars are often faced with difficult moral decisions. For example, if an accident is unavoidable, should the car prioritize the safety of the passengers or pedestrians? These ethical questions raise important concerns about how autonomous vehicles should be programmed to handle emergencies. Regulations and safety standards. Another challenge is the regulatory environment. Different countries and regions have varying standards for self-driving cars, which means manufacturers must ensure their cars comply with a wide range of laws. Some countries, like the United States, are already testing and deploying autonomous vehicles on public roads, while others are still developing their regulations. The future of self-driving cars. The future of self-driving cars looks promising, with significant advancements happening every day. Companies like Waymo, Tesla, and Uber are continuously improving their autonomous systems. The goal is to have fully autonomous vehicles on the roads without the need for human intervention. In the next decade, we may see self-driving cars become more commonplace, with fleets of autonomous vehicles offering shared rides. These vehicles could transform cities by reducing traffic congestion, lowering accident rates, and reducing carbon emissions. Additionally, autonomous trucks could revolutionize freight transportation, making deliveries faster and more efficient. The tech behind self-driving cars is nothing short of remarkable. From sensors that give cars sight to artificial intelligence that powers decision-making, these vehicles are equipped with an array of cutting-edge technologies. While there are still challenges to overcome, the future of autonomous vehicles looks brighter than ever. Whether you're excited about the convenience, the safety improvements, or the environmental benefits, self-driving cars are set to reshape the way we think about transportation. If you enjoyed this deep dive into self-driving car technology, don't forget to hit the like button, subscribe to the channel, and ring the bell for more amazing videos on the future of tech.